Okay, now let me do the assignments again. Now basically I've switched the editor to VS Code for a little bit easiness, but I don't see any easiness here. Just the thing is the fact that, you know, I do not really like the live preview now because the document is a little bit lengthy and I only want that to be compiled when it is saved, right? So basically that is the case. Okay, so I've been doing these. These are the equations now. So I think I have to write the algorithm for this thing. Okay, so this thing is the thing, and I have to write the algorithm. Now, in order to write the algorithm, all I can do is, now there is a concept of macro, okay, and algo is basically a macro I created in order to write algorithms, okay. So that is not the you know, kind of the de facto macro or de facto standard macro for LaTeX. It is another. There is algorithmic package. There is pseudocode or something package. Okay, so these are the packages. But I'm going to use algo. That is not anyone's package. It is just my package. So I'm going to use that. So basically, now what you're going to do is you're going to do start. Okay, algorithm start, and here in order to find the quadratic, you know, you have to read coefficients. To find the quadratic roots a, b, and c, and what you can do is print f, right? Those are the if. Now there is an if statement. If, I think there should be math mode is better here, b squared minus 4ac is maybe I'll write just is greater than equal to 0. And what you're going to do, so the thing that we're going to do is in sub item, so print, I think you have to compute it first, so compute. So what is the formula for that? I just forgot it. So b squared I think, yeah, dfrac minus b plus minus dfrac square root of what is it, b squared minus 4ac, right? And 2a is that. So let me see. So that's compiled. Now let me see the algorithm right here. Okay, compute this one. Compute and print. I think I have to write it compute and print because algorithm is, you know, the code is print, so it is done in the same place, so why do I bother doing that? So else it's going to be sub item, so compile, compute and print. So if it is else, that is if it is not the case that we have just shown here, that is the roots are imaginary. So if the roots are imaginary, then you know, young t this one, and you're gonna just paste it here, paste it right there. Okay, so what you have to do is you have to, you know, enclose this into bracket, and what you're gonna do is you're gonna do minus here. Okay, so yeah, so that is the case, and minus you're gonna do that, compute and print this thing. And the algorithm is a little bit, you know, kind of a little bit absurd or something like that, because I've just done this in one line, right? So since I've just done this in one line, I think this is it. I don't think I have to, you know, think about it more than that. Okay, so why should I think about more than that? Because it is what it is, right? Algorithm is here. I think I have to do the output again. Output. So for output, I have also a macro, okay, to make your code a little bit cleaner. So what I can do is you can just copy this thing. Oh shit! What the heck is happening? So in order to copy these, why the heck is not happening right here? 1 minus 5 6. So you're gonna copy these. Wait, what the heck is happening? Wow, man, wow. What the heck? I think I have to close this. CD, projects, C projects, and C lecture. As quadratic equation. So quadratic equation 28. No. 1 minus 5, 6. So it has been solved here. Okay, it is selecting. So it's selected like this. That's it. Okay, it has been selected. So I can place it real quick. Okay. So just paste it here. Basically that is the case. Now go to the end. I'm going to break a new line, so I think the output is going to come like that. So basically I have not taken any screenshot of it because I do not know why I should take this screenshot. It's just a shitty thing to do. Alright, so that's it. Another thing that I'm going to do is prepare a flowchart. Now I think I have to do it before algorithm or where. I don't really know where to do it because anyway the thing is going to be there. So after algorithm this time. Previous I didn't do after algorithm, but whatever. Okay, after algorithm, let me do flowchart. And another macro that I developed is flowchart. So flowchart. So you may say flowchart is maybe very difficult in LaTeX. It is not so difficult, but it just takes a little bit more time to get used to. But once you get used to, then it's just intuitive to work with. So the first thing that you're going to do is you're going to draw help lines. So you're going to draw help lines whatsoever. So 7.5, there's not that great use of help lines here, but still there is some use. So grid 7.5 and minus 20. So and now node, I want start node. So is the type start, and I'm going to write capital start here. So if I compile this, then the thing that is going to come here in the other page maybe, or the here. Alright, so the thing that is going to come is start here. After start, what I want to do, now there is no any reason to look at that PDF again and again, because if this is intuitive to you, if you're getting used to it, then it is just simple. So here it is node, this one, and you want to add some node again. So another node that I need is input node. So input, I'm just going to write input. That is the IO node, and it is going to be below of the start thing. And it's going to have written read coefficients A, B, and C. So that's it, right? So compile it. And it should be compiled now. In order to draw arrows, there should be another command. Okay, arrow like this. Okay, draw arrow from start to input. So the input spelling is a little bit weird. So okay, so you should compile it again and again to see whether it is working or not, but there is no any reason to just look at that. So node, and another one is we're going to having decisions. Okay, we're going to have decisions, sometimes tongue slips. Okay, node, what you're going to do is you're going to have a decision deck. So decision. So decision should be below of, below of input, and it should be y shifted. Y shift, maybe minus 4, it should be enough, right? Minus 4 should be enough. So here it should have, decision. If write this thing here, b squared minus 4ac is greater than equal to 0. What the heck is going to happen? Then basically that is the case. So compile it. Okay, so that's it. Let me take a look. Yeah, that's cool. So if that is the case, then that is the thing. I think I have to add minus 50. If if I do this, then it will shift to the left. It is helpful because if that is in the left, then we can work with those things easier. So here, point C, okay. Now you need another node. Okay, you're going to need another node. What kind of node do I need? I need the kind of node that is compute and print. It means you need a process now. So process. So you're going to do process. You can do that is process, and below of deck and X shift, that is Y shift. Should be -2 centimeters. That's going to be enough. So don't forget the semicolon. So here what you're going to do is you're going to write the process. What is the process? The formula. So I'm just going to copy the formula. So dt and this one. Okay. Oh, sorry. YT and this one. And I'm going to just paste it off. Alright, so this is the formula that we have here. Yeah, and we can just yank it in. And alright, so after that what you can do is you can have the other one. Okay, you can have the print. So node input output 1, maybe input output 1 IO below of process. It is going to be print result. So basically I can even write here result is equal to, okay, so okay, it'll compile normally. Okay, so these are the things. I think Y shift is a little bit more for this thing. Two is enough. Alright, so that is it. So after that, what I'm going to do is, now if this condition is true, I'll compile it. If this condition is true, okay, this condition is true, then it is going to do like this, print result and exit, right? After that we need an exit thing. So in order to do that, we need an exit thing. So node exit, the type is start, and below of is IO1. So basically stop is what is to be needed here, right? So you can just save it and you just have it. So the another thing is that when the thing is not true, that is IO2 now it is going to be IO, and it should be right of the decision, and X shifted is equal to maybe 3 centimeters, and what you have to do is not IO, it should be process 2. So okay, now what you have to do is you have to process another one, maybe YF, no, from here, YF. So you can just paste it. So here you're going to result is equal to this thing here, and basically you're going to have here minus and everything. I just said before. So let me just check it. That's okay. I think X shift is a little bit less, so let me do it full. So again, what I'm going to do is you're going to need node for printing, that is IO2, and it's going to be like IO, that is input and output, and it should be below of should be below of process 2 to be executed. Here print result. Okay, so that's it. So flowchart is nearly completed. The only thing that is missing is the arrows now. So drawing the arrows is pretty easy. That is not a difficult thing. Just draw arrow from start input. What arrows are drawn already? So it is from input to deck. So input to deck. So similarly, draw arrow. So deck to where? From deck to where? It's going to take from deck to process, right? Process. So node is going to be position is 0.5 left. It's going to be left, and no, because the condition is false. When we check the condition, that is false, right? Here, if it is no, I think that is yes. Okay. If it is yes, then so draw arrow, and from process to result from IO1 to exit. Similarly, draw arrow from decision to process 2. Node position is of course 0.5, and above is no, basically. So similarly, draw arrow from process 2 to it is going to be IO2, basically. So from IO2, so the last arrow that we're going to draw is from IO2 to exit. So IO2 is going to be like 0 and -4 maybe. From it is going to be to exit. So we compile it. Yeah, done. So 4, 5, 6. 6 is needed. So 6. Alright. That's it. That's our flowchart completed. Now basically let me cross check it, reload the code. Now if it is no, then result is this one. If it is greater than 0, if it is not, then result is this one. If it is yes, then result is this one. Okay. So yeah. So another arrow is forgotten. From deck to what? Not deck to. It is from process to IO1, basically. Right. No. Okay. So I think I can comment this help lines out. Help lines are just for help, as you think, right? So look at that nice flowchart created with LaTeX. So you can comment that this flowchart, it is so perfect, right? Kind of perfect. So it looks professional. Alright, so let me move to another question. Another question here is explain the corresponding write a program to evaluate the following function. Fx is given by. Now this program is a little bit complicated maybe, right? Write a program to evaluate the following function. Subsection. So write a program to evaluate the following function fx given by. So in order to write this, I think I have to use tabular. Okay, so tabular is the thing to be used in order to write this. So I'm going to do begin center. So in the center, what I'm going to write is begin tabular. So, or you can also use align, maybe, right? Can you use align with that? Maybe. Let me do tabular. So in tabular position follows is equal to basically. Columns are just 2, so C and C. And tabular, this one is here, on the table here, so H. So what I'm going to do is you're going to write and a bunch of times. 1 2 3 4 5, so 5. Here what you can write is, so is equal to 0 if x is less than or equal to 0, is equal to x minus 10, x minus 15 if 10 less than x less than or equal to 5, right? Similarly, this one is going to be x minus 10, x minus 15, x minus 20 if x is equal to 10 less than or equal to x less than or equal to 15. So here x minus 15, x minus 20, x minus 30, and if 15 less than x less than or equal to 20. 20 again, here we're gonna have this thing here, it's gonna be is equal to I'm forgetting to write equals to, is equal to what, x minus 20 minus 20, x minus 30, x minus 40 if 20 less than x less than equal to 30, equal to 0 for all other cases. Now there can be errors here. Yeah, I knew that error can be there because, you know, many times it happens. Missing x inserted. So basically the first thing that happens is this one. Now this one, if this one is okay, this one, yeah, should be here. I think it is okay now. Maybe, but well, this one is it okay? No, it isn't. So the first thing is this one. This one is 1, right? And that one is other. This one is 1 and this one is other. This one is 1 and that one is other. Here. This one, I've forgotten to do it in every step. Yeah. What has happened now? So this one is, yeah, here. Okay, I think it will compile now. Okay. Now fx is there. So compile it. 3 fx is equal to, real quick, not center, this should be left. Alright, fx is this one. So similar to the question what it is written. I forgot how to use that bracket. Maybe I'll look at the manual here. There was a cheat sheet right here. I'll look at the manual where we can get the curly brace from. So basically, sometimes it's important to have the, you know, here the manual angle this here was that, but I've forgotten it. I can leave it. What I'll do on our Z. This is what it has been typeset in the book, so I'm going to write the same thing. Okay. Now, since it is over, what I have to write is we have to write the code, which is a little bit cumbersome for this kind of problems. Okay. It is very cumbersome to do. 1, 2, 3, 4, 5, 6. So basically, we should use else if to do this. I think, yeah. Okay. There's using else if structures. So move to the third one. And cd in home. Okay, I'm going to stop the record now. I'm too tired to do any homework.